Good morning, Virginia. Um, Let me see. Yep. Oh, so it is working. Hold on. There. Yeah, I was telling you. I wanted to make video lessons about the lessons, and in this way, you can practice at home whenever you need to, whenever you have time. Yeah. The lessons are gonna look like I'm gonna go from the book. I'm gonna go from the book, by the book, because in this way, well, you already bought the software, so we might as well use it. So we need to go by, well, we don't need to, but let's do it this way. Let's work with the book instead, the lessons from the book, and in this way I can go over the material from the book, just the way it is written. In that way, if you want to bring notes to class, like if you want to print these pages, remember to go to the media library and then choose the chapter and section and choose book, and it's going to take you to the book, and you can print from there. And let me see what else. And let's do it this way. In this way, you practice before you come to class, and in this way you can also you're gonna be ready for for class. If you watch the video before you come to class, and then when you get to class, we can just practice as much as we can. In that way, I can see if you are memorizing, and if I see you're making mistakes, common mistakes, I'll let you know. We correct them, and then we go from there, and then you'll be ready for the assignments. Okay. So yeah, I'm gonna go by the book, and in this time we are on chapter 9. Yep, we start in chapter 9, and the section is 9.1, as you can see here. And I'm gonna go ahead and make it a full screen here, and start there. Okay, and let's see. In this chapter, the title is Graphs and Applications of Linear Equations. Well, all that means is we are gonna be working with graphs. In other words, we're gonna be working with the plane, Cartesian plane. You don't have to know that. You don't have to know that name. Just know that it's gonna look like this, something like that. And equations, when they talk about equations, they talk about equations that look like they have two variables, okay, y and x, because so far we've been using equations with only one variable, the x variable, to be more precise. However, now we're starting to work with two variables, okay? So the equations are going to look like this. So instead of solving for x, the equation is to be solved for y, to make it easier on you, okay? And you'll see why in a minute. Anyway, that's the introduction there. So let's go back to the beginning here. Let me tell you what you need to know and what you need to memorize. Well, in this case, graphs. Just know what graphs means and the word. Be familiar with it. Okay, so let's go to section 8. Plotting order pairs. Plotting order pairs. all that means is they're gonna give you a pair of numbers. In this case, it is called an ordered pair, well, ordered pairs, and they call it that because, and yeah, you need to know that, you need to memorize that. So I'm gonna go ahead and underline that ordered pair. Make sure you memorize that, and you don't have to know the rest of those words. Just know that an ordered pair looks like this. It's it has an X value to it and a Y value to it. X, Y. We always start with X for the first value and Y for the second value because that's the way it comes in the alphabets. X comes first, Y comes next. And those are the two variables we're going to be working with, the only two variables, X and Y. Okay. Remember that, and let me get a piece of paper so I can make it. I can make my point. Remember that when we've been working with number lines, right? So you're familiar with number line already. You know that the numbers to the right are positive and the numbers to the left are negative. Okay, so yeah, make sure you apply that knowledge here too. It's okay. In the case of graphing, this number line, the number line that you're used to, is called the x-axis. X-axis. Okay. And you need to know about that name now. Okay, that's the x-axis. Positive values are to the right, negative values are to the left, and we are gonna add just one more axis there to the number line, and it's gonna be a vertical axis, and the name of it is the y-axis, and you need to know that. You need to know these two terms. Well, let me go ahead and write it here. X-axis and the y-axis. All right, and memorize those. Let's see what else. And for this axis, the y-axis, yeah, we still the middle point should be the zero line, right? Yeah, except for now the positive values are to the top, the negative values are to the bottom. That's the difference. Okay, positive values at the top, negative values at the bottom. Okay, that's important. It is important because we will be graphing points, plotting order pairs, and you need to know whether the x values are positive or negative, and whether the y values are negative or positive or negative. Now, for example, here with this point here, the x value 3 is positive, and then the 4, the y value, is also positive, and so is for this one. Now let's say I was plotting a point here. Well, the way I would like to do it is I use the x-axis first. I run on the x-axis first, either to the right if the numbers are positive, or to the left if the numbers are negative. Okay, and then from there I either move up or down If the numbers are positive, I move up. If the numbers are negative, the y values are negative, then I move down. So let's say I need to go to this point here. Well, I start from the origin. The origin, that's the 0, 0 order pair, and that is spelled like this. Origin is this point. Well, yeah, the zero line, yeah, for both the x and the y axis, 0, 0, or the order pair 0, 0, yes. And remember that order pairs are points on the graph also, okay? So that's synonymous. A point is equal to an order pair, all right? So if I want to plot an order pair here, well, I'm moving my x-axis first. In this case, I'm moving negative 4 to the left, because my point is on the left here, the left of the 0 line here. So a negative 4, I move negative 4, and from here I either move up or down. In this case I move down, that's negative, see negative values. So my y coordinate is negative 3, okay? So my x value is negative 4, and my y value, comma, my y value is 3, okay? You need to separate the x and the y values with the comma. Make sure you get used to this format here. This is an order pair. This is how you write an order pair, okay? With parentheses, the x value comes first, the y value comes next. All right, let's move on. Hold on. And then from here, let's go to an example. Well, example 2. Well, there's example 1, you know, if you want to look at it, but I think we already worked on plotting a point already, so you are familiar with it now. But let me go ahead and plot this one really quick, because it is important to remember that you always move on the x-axis first, like on top of it, like literally on top of it, okay? And then from there you either move up or down. You do not go back to the to the y-axis and move up and down or down there. No, wherever you land on the x-axis, you either move up or down, okay? So for example, if I want to plot that point negative 5, 2, I move on the x-axis first. I move to the left because you have a negative 5 there. So negative 5 units to the left there, and from here I move up or down. I do not go back to the y-axis. No, that would be a mistake. So from here I move 2 units up because the 2 is positive. So I move up 1, 2, and plot my point there. Plot there, and that's my negative 5, 2 points or order pair, okay? All right, so let's go over to example 1, see what that looks like when plotting. Yeah, and you're gonna have question like this, okay? On the assignment, and of course on the test too. And it's gonna look something like this. So get familiar with the questions, the kind of questions they ask. Okay, plot the point. It literally means plotting the point on the graph. Okay, and then are also gonna have this kind of questions. In which quadrant, if any, are the points, all these points, located? Well, for that we need to know what they mean by quadrants and where they are and how to label them, okay? So in this case, quadrants are when they talk about quadrants, they talk about these squares the squares that the y and x axis make when they cross each other. So we only have 4 basically, and we can make it bigger, as big as we need to. In this case we don't need to, so but you're only gonna have 4. You're always gonna have 4. And the best way to remember how to plot them is that or how to locate them is that the first quadrant is here, because you have positives and positive values, and then the second quadrant is here, and then the third quadrant is here, and then the fourth quadrant is here. Okay, so you need to know that. And the best way to remember, see, because you're not going clockwise, we're moving counterclockwise, and we don't even start up here, we start over here. So it's way different, more different than looking at a clock. Okay, the best way to learn this is to think about this as being the 0 degree right here, 0 degree, and moving this way to 360 degrees. So because whenever you talk about degrees, you move this way, counterclockwise. So if you think about it that way, you know that you start here, and that should be your first quadrant. If you think about this as being degrees, the first quadrant, then the second should be here because you're moving left, like this, counterclockwise. All right. So make sure you memorize this too. First quadrant, second quadrant, third quadrant, fourth quadrant, and let me go ahead and highlight it because that's important. You need to know that. All right. Well, we need to know which quadrants these points are in. Well, let's go ahead and work with -4, 5 ordered pair. -4, like I said, you move on the x-axis first. -4 is here, and then you either move up or down for your y variable. In this case, we have +5, so you move up 5 units up and plot your point there. So it landed on the second quadrant. So the first point, the first order pair, is on the second quadrant. All right. What about this one? That's a +5. Okay, we start at the origin, move to the right 5 units because we have a +5 there, and then from here I either move up or down. In this case, we have a negative value, -5, so I move down 1, 2, 3, 5 units, plot my order pair there on my points, and we see that we landed on the fourth quadrant. Okay, so this point is on the fourth quadrant. What about this one? That's a +2, 1, 2, and then +4, 1, 2, 3, 4, and plot it there. And we saw that it landed on the first quadrant. Okay, so that's where it's located. What about this one? That's a -2, 1, 2, -5, 1, 2, 3, 4, 5, plotted there, and we saw that it landed on the third quadrant, so that's where it's located. What about that one? And it's -5 and 0. We don't move. See, we don't move up or down because the y value is 0, so we plot the point there, and now we can see that this point is in neither quadrant. It's not on that one, it's not on this one. So the answer should be something like it is on an axis and it's not in any quadrant. Okay, that should be the answer for that one. Okay, and that's one option that the software is gonna give you, so it's gonna be easy to spot. Okay, but just make sure that whenever you have a point landing on your axis, they are neither on neither on any of the quadrants. And so you need to write, well, you need to choose the answer. It's not on an axis, it's on an axis, and it's not in any quadrants. Okay. I repeat that because it's important. Okay, let me write on the page here and move on to section B, because now we need to learn how to find coordinates. Okay, so let me, where's this one? No, there. All right, finding coordinates. Well, this is, if you think about it as being the opposite of what we did. So because now they gave us the points or the ordered pairs. Well, the points in this case, we need to figure out what the ordered pairs are. Okay, so you're gonna have questions like find the coordinates of points A, B, C, D, and so on. So all of this. So they're gonna give you a graph with all the points plotted on there, and you need to find the coordinates. Okay. Again, it's you can think about it as moving backwards, or you can just go like, for example, point A is way up here, and you can ask yourself, well, I need two values. I need the x and y value, right? I need the x and y value. Well, what is my x value? Well, I can see that my x value is -3, and my y value, well, my y value is +5, and that's it. Point A, the order pair for point A is -3, 5. -3 +5, yeah. All right, what about B? What's it? Oh, right here. Okay, for B, we need an x and y value, right? So my x value is +5, see, that's 5, and my y value is 1. All right, then for my see, oh, right here, so it's right there, and my, I'm gonna do that. For my x value, that's gonna be a -4, and for my y value, it's gonna be a -3. See, so that's how you do it. All right, so let me just make sure that it's recording here. Okay, yeah, it looks like it's recording, so that's good. Okay, so let's move on, and that's it for section B. So let's move on to section C here, and this is really not that hard. You just need to practice though. You really need to practice. Anyway, for section C, we need to find solutions of equations. Well, whenever you're talking about solutions in algebra or in mathematics, you're not talking about what is the answer. No, not necessarily. No. If I ask myself, what is the solution of this equation? I'm talking about what order pair is going to make this equation true. In other words, when I plug in, I need two values. Will that give me the same on one side of the equal sign as it will on the other side of the equal sign? Say like this, that statement is true. If it does, then this order pair is a solution of this equation. Okay, so that's what I mean by solution. and you need to memorize that. Know that it doesn't necessarily mean the answer, just like you have learned all these years. No. In algebra, it means either one value, or in this case, two values that make the equation true. Okay. And oh, my bad. That's not the word I wanted to underline. Solution. I meant to underline the word solutions. My bad. Hold on. Solutions of equations. Yes. This is what I want you to memorize. Not this. I saw the letter S there and it threw me off. Anyway. Oh no, yeah. I knew I had seen it before. It's down here. Solution. Yeah. Oops. There. It's right there. Solution of the equation. Yeah. Memorize that, and in that way you know what they're talking about when they ask you questions like this. Determine whether each of the following pairs is a solution of AQ minus 3P equals 22. Okay, so all that means is, again, which of these ordered pairs, when substituting it for your x and y variables, well, in this case is they chose Q and P and Q, because you can choose any variables really, as long as you use the alphabets. What I mean by that, because if you are thinking about ordered pairs, remember that the first variable comes first in the alphabets. Okay, so if I'm using Q and P comes first in the alphabet, therefore you have to write it first. Okay, therefore this is gonna be your first variable, and then Q. Okay, then Q. So in this case, your P is 2 and your Q is 7. P and Q. P and Q. Okay. Okay, so P and Q. Yeah, so now we know that which variable is P and which variable is Q. Okay, so we said that P comes first, therefore the number 2 is P, so that goes here. You substituted for P into the equation, the equation they gave you. Okay, so in your case you have to rewrite it. Make sure you rewrite it. So let's say I'm right here. What I would do is I would rewrite the equation on my paper, the whole thing. Yeah, equals 22, and then substitute right underneath, because this here I can tell exactly where I need to substitute. And since I know that Q is 7, I will substitute that in here for the Q. And since my P is 2, I will substitute that here for the P, for the variable P. Rewrite everything else. And now you have an equation that looks like this with constants, no variables at all. Okay, and let's see if this is a solution of this equation, because 7 times 4, because this means multiplication, right? So 7 times 4 is 28, minus, and 3 times 2 is 6. Okay, rewrite everything else, and now you're here. Yeah, the other operation is multiplication first. That's why I didn't subtract these two. Okay, so be careful there. Now I can subtract. 28 minus 6 is 22. Rewrite everything else, and notice that this is equal to this, so this equation is true, this statement is true. Okay, so yeah, this order pair is a solution of this equation. Okay, because it made the statement true. All right, let's try the other one. This one, -1, 6. Again, make sure you rewrite the equation on your paper just so you can have it right there. In this way, you know exactly what to substitute. So here I need to substitute Q, and I know that Q is 6 because Q comes first. Q comes second on the in the alphabet, or comes next after P, and then that's -3 times my P. P is -1. And all of that is equals 22. All right, and now I'm ready to perform the operations. 4 times 6 it's 24. 3 times, well, in this case I have -3 times a -1. Let me see. So that's +3 equals 22, and then 24 plus 3 is 27 equals 22. Okay, and we can see that the equation is not well, it's not true, so it's false. So in this case we have a false statement, false. Therefore this order pair is not a solution, not a solution of the equation. Okay, all right, and yeah, that one's true, this one's false. Okay, all right, let's see if we can practice some more here. So it's just going to different questions, sort of. Show that the pairs of this are solutions of, and in this case they gave us a different equation, y equals 2x plus 1. Then graph the 3 points and use the graph to determine another pair that is a solution. Okay, let's go step by step first, because it is a 2-part problem. That's okay, we can do it. Now they gave us 3 points because that's how many points you should plot on the graph to be able to graph the equation properly, because you're going to be tempted to use only 2 points. However, that's it may be correct, but you may end up making mistakes, because if you do not add a 3rd point in there, then you probably won't see that your equation was curved, your graph was curved, and then you're gonna plot it that way, and it's gonna give you the wrong answer, the wrong graph. So hold on, let me see if it's still recording. Oh, that's good, that's good. So anyway, let's move on. Okay, so where was I? I was right here, and I was talking about oh yeah, we need to see if these order pairs are a solution of this equation. Okay, again, let me go ahead and write the equation here so I can have it right there. 2x plus 1. Let me go ahead and write all of them. Y equals 2x plus 1 and y equals 2x plus 1, and that way I can work them out all at the same time. And the order pairs are 3 and 7. In this case we have x and y variables. I know that x comes first in the alphabet, so 3 is gonna be my x. Okay, so y is gonna be the 7 there, so substitute 7 for y, and then substitute 3 for x. This one. Same for this one, y is 1, and substitute 0 for x. Rewrite everything else. The same thing with this one. Y is negative 5, and x is negative 3. Rewrite everything else. Alright, so now we have our 3 equations. Alright, so here what I need to do is just go ahead and follow the order of operation. Yeah, you still have to be careful with the order of operation. Okay. 2 times 3 is 6 plus 1, that's 7. So that's true. That gives a true equation. What about this one? 2 times 0 is 0. Rewrite everything else. 1 equals 1. That's true. Yeah, that's also true. So this order pair is a solution of this equation. This order pair is a solution of that equation. Okay, of the same equation. Notice that we have more than one solution. Okay. Now what about this one? Well, I need to multiply here. 2 times negative 3 is negative 6 plus 1. Negative 6 plus 1. It's the same thing as subtracting. 6 minus 1, 5. Keep the sign of the largest ones, largest value. That's negative 5. Rewrite everything else, and this equation is also true. All right. So all 3 equations were true. So in this case, all these 3 order pairs are of the same equation. And now we are able to plot them, and we know that because we know that these are solutions of the equation. What does that mean? Solutions of equation? Well, we already said that it meant making the equation true. Order pairs that make the equation true. Yeah, that's one. Well, that's one way to think about it. The other one is that when you plot them, for example, here we plotted all 3. It is 3, 7, 0, 1, and negative 3, 5, negative 3, negative 5. So that's that one, and that one, and this one here. Those are the 3 points. three order pairs they gave us, and we already knew that that they were solutions. See, we already knew that there were solutions of that equation. So we went ahead and plot them. By the way, if you can get some graphing paper from the store, that would be nice, because that would make your life easier. It will make the graphs a little more accurate, and that will help, because remember the question, one of the questions was what are the points and use the graph to determine another pair that is a solution, another pair that is a solution. So we are here, we already graphed all those points, and now we need to determine another point that is a solution. What does that mean? Well, it means that this graph is made up of a lot of points, an infinite number of points, okay, on the graph, yeah, on this plane. So they are asking us to give them another point that is also on the graph. That's basically what they're asking, since all of these points are going to make the equation true, okay? Not any of the other points on the plane, no. In this case, we know that the point 2, 5, or order pair 2, 5 is gonna be on the graph, because it crosses here at the intersections, okay? So that's one easy point to determine, you know, to know the x and y variables, x and y values, because it crosses at the intersection, okay? Notice that a point here, like inside the box, we wouldn't be able to know what the exact values are, because it's too difficult to determine. Therefore, you need to look at where the graph crosses at intersections on your graph. See, like right there, that's another point that you can look at and see that it has a value of x equals 1 and a value of y equals 3. Okay, so that's another point that you can use. Let's see, here it crosses at this intersection, so that's another point you can use right there. Here it crosses at this intersection, that's another point you can use. -2, -3, all right, and so on. Okay, in this case we only chose this one, okay, but you could have chosen either this one or this one or this one, okay? And that's it for that example, okay? So let's move on. And well, in this case, what we said, we chose 2 and 5 for the extra points, okay? And in this case, they went ahead and plugged it into the equation, substituted values into the equation, and it turns out that the equation is true, and it should, because we got it right out of that graph, okay? We got it right out of the linear equation there, linear graph. All right, so let's move on to section D. Okay, let's see, there you go. So we're gonna be working with graphs of linear equations. Well, we still are working with graphs of linear equations. Okay, let me see, the from equations, the geometry represents all equations. Yeah, well, if you didn't already get this, make sure you understand what that is. When we say the word graph, it doesn't just mean drawing the graph. It also refers to the equation, to the drawing that represent all its solutions. In other words, this drawing here, this is a graph. This is the graph. That's what that means, okay? When we're talking about graph, it doesn't just mean graphing it, it means the graph too. So it's it has two different meanings there, okay? So let's move on. And in this case, they are called linear equations. You don't have to know that, but it would be easy to remember because let me underline that, let me highlight it, because all our graphs are gonna look like this, just a line on the graph, on the plane, just a line. So they are called linear equations. These are linear equations. These are gonna yield just lines on the graph, this kind of equations, because they have powers of 1. See, you have powers of 1, this one has a power of 1, so they are gonna yield linear equations, linear graphs. So just a line, that's what that means. And that's all we're gonna be working with in this class, just linear equations. So all our graphs are gonna look like lines, just lines on the plane, okay? And not curves or anything like that, okay? Okay, so yeah, from here we go to move on to graphing the lines when we have an equation like this that looks like that, okay? So what they are suggesting is that we do it randomly, because we do it by trial and error, because and let me show you this example here. Let me work it out. Let me get some paper here. And we have the equation of y equals to x, and you don't have to draw it like this, you don't have to draw a table like this. It's just it's too much work. Let me show you what you can do. You can, let's see, you can draw a table that looks like that. I'm just gonna put it over here. You're just showing your x and y values, x and y values, and then draw a table that looks like that. See, we could have plotted all these points, well, written all these points here without having to draw a table that look like that, okay? And what they suggest is that you draw your point, you start with random values for your x, and you always start with your x, okay? If you want to, it makes it easier. Just give it random values. Give random values for your x. Just make sure that they are small, the smallest ones you can find, because if you choose large numbers like 1,000, 3,000, something like that, you won't be able to plot them on your graph. See, because on your graph you're only going to be able to maybe get at most 20 units to the right, 20 units to the left, and 20 units up, 20 units down, maybe at the most, if you count by twos. So yeah, you need to use small numbers for your x variable. Okay, so we chose this at random. So let me make a note here. Notes chosen at random. So I just came up with these values for x. Okay, so that's the way you need to start. Okay, and the equation is y equals 2x. Okay, so if I chose, and I don't worry, I'm not going to worry about this. I'm going to use my own table here. Okay, because it's simpler. It's a lot less work, and you can use this table again and again. Okay, so the equation was this. I wrote it down here just so I can have it right next to it, and I said that I chose my x values at random, and they had to be the smallest ones you can find. Okay, and they can be positive and negative if you want to. Okay. Okay, so the next step is to find the y values. Since I chose my x values at random, I need to find new y values. In other words, these are going to be order pairs, right? Because remember that your order pairs have x and y values. Okay, so this, so I'm going ahead and just this time I'm going to draw parentheses around them, just like you would write order pairs. Okay, so here I know that I'm missing a y variable for all these order pairs. Okay, and then for the y value there, I mean for the y value here at this step, for this order pair, I know that my x is 3, right? Okay, so let me go ahead and rewrite that over here. Oh, let me go ahead and write the equation over here, 2x, and just substitute underneath for the x, yeah, for this x here, substitute it for 3. See, because I want to find the y value for this order pair. Okay, all right, so if I do that, I'm gonna have that y equals 6. 2 times 3 is 6. So this, so whenever I plugged in the value of 3 for the x into the equation they gave us, I got a y value of 6. So that's my order pair. Okay, so that's how you get your order pairs at random. Choose your x values at random, use the smallest numbers you can, as small as you can, you know, and then plug in the values into the equation and solve for the y variable. All right, let me rewrite my equation and substitute the x value for the next order pair, which is 1. So now y equals 2. So the order pair for this one is 1, 2. Okay. Keep doing the same thing with the rest of this. I'm just gonna do the work underneath here, and my x value for this order pair is 0. So 2 times 0 is 0. So my y variable is 0. All right. So what about this one? Well, let's substitute -2 for the x, and negative and positive and negative multiply times a negative, it's gonna give me a -4. So that's the order pair, -2, -4. What about this one? Well, that's y equals 2 times -3. That's y equals -6, because a +2 times a -3 is gonna give me a -6. -6. So the equation and the order pair is -3, -6. And we are done choosing order pairs at random. See, that's how you do it at random. That's how you do it choosing that's how you choose points at random or order pairs. And you get random values for x first. Choose the smallest ones you can and substitute into the equation they gave you. Do that for each order pair and you should be able to find the other the y variable. Okay, so now we have that, and now we're ready to plot them. Okay, and here they are. 1 2 3 4 5 1 2 3 4 5. Here are all of them, all my points. Okay, and remember that to graph it you only need 3 points. In this case we got 5 of them. Yeah, but that's even better because I can see that all those points are on the same straight line. So if you bought graphing paper and you were plotting them, you could see that they are all on the same line, a straight line. Oh, and by the way, you may need a ruler too if you don't have one. Yeah. And that's how you do it. That's how you graph. That's how you graph equations on a plane by getting points at random. See, because we started here, we started right there with nothing at all, just equation. Okay, and just with that we were able to graph equation. Okay, because we chose x values at random, and from there we used the equation to get the y variables, and that gave us our ordered pairs or points. We plotted them and we got the graph. All right, that's how you do it. All right, let's go to the next example then. Let's see what was that. Okay, well, let's see if we can do the same thing here. They gave us well, they worked it out already for us, but we are gonna just focus on the graph, I mean on the equation, and go from there. All right, because like I said, you can graph the equation just with this information, -3a, and this is the way you need to do it. Okay, this is the way you need to work it out. So I'm just rewriting my equation here so I can have it next to it, next to my work. Now I'm gonna go to my work here. Let's see, there. Okay, and again, image froze, hold on. Again, all you need is a simple table like this. Yeah, and I said that you only needed 3 points, right? Or at least 3 points. Don't do 2 because 2 might be misleading. Okay, so do 3 and use the smallest values. Well, I'm gonna use 0, positive x, I mean +1 for x, and -1. See, the smallest ones I could find. I don't have to make my life hard. I really don't, because this might give me the right graph. Okay, so now that I did that, I'm gonna go ahead and find the y values using the equation. Okay, so the equation is, and I will rewrite it over here to the sides, 3x plus 1, and I know that for the first order pair my x value was 1, so I need to substitute that into the equation, rewrite everything else. Go ahead and perform the operations. -3 times 1 is -3. Rewrite everything else. Keep going. -3 plus 1 is -2. Okay, and -2, that's my y value that I got from using the +1 into the equation. Okay, let's do this one now. Y equals -3 times 0 this time. Okay, and you don't have to put your work all this close because you're gonna get confused. So if you have room, make sure you do it somewhere else, okay, separate from this. I'm only writing it so close because I don't have much space to work with. Okay, anyway, rewrite everything else, perform the operations. -3 times 8 is 0. That's gonna give me a 0. Plus 1, y equals +1. So that y goes in here, okay, for that ordered pair. All right, so let's do the other one. It's -1. Y equals -3 times -1 plus 1. Perform the necessary operations. -3 times -1 is +3. Rewrite everything else. Keep going. 3 plus 1 is 4. So y equals 4. Alright, so now I have my 3 ordered pairs. And if I did all my work correctly, this should be the right ordered pairs. Okay. So let me see if I can plot them over here. All right, -1, I mean yeah, I'm +1. First order pair was +1, -2. Okay, so again you start at the origin and move +1. Let me get this even closer. There, +1, -2, 1, 2. Plot my point there, and I can see that it is on the graph, so we did okay. What about this one? 0 for x, 1 for y. 0, well, I don't have to move to the right or to the left. I stay right there at the origin and just move up 1. Plot the point. So yeah, that is also on the graph. So we did good there. What about -1, 4? Well, start at the origin, move to the left 1 unit, and 4 up, because that 4 is positive. Okay, -1, 4, plot your points, and we did good. We found 1, 2, 3 points to graph this equation. They use a different point, and that's okay. You don't have to use these 3 points. I chose them because these were the smallest values I could use. Okay, well, these were the smallest values I could find, and those were the smallest values that could give me digits here and not fractions. Okay, all right, and that's how you do that. Just with the equation they give you. That's how you graph your equation by choosing values at random. Okay, let's see what else. Okay, so in this case we have a different question, okay, and you need to remember this. Graph y equals 2 over 5x plus 4 and identify the y-intercept. Okay. Y-intercept, you need to remember that. What is the y-intercept? Well, it's right there at the top. The y-intercept, as its name implies, let me get this out of the way. Hold on. As its name implies, let me see, right there. It's where the graph crosses the y-axis. Okay, that's the y-intercept. In other words, the point to the order pair. That's where the graph crosses the y-axis. Okay, so that's the y-intercept. You need to know that, to remember that. Okay, memorize that as soon as possible. All right. So the question is asking us to graph this equation and identify the y-intercepts. Okay. Well, in this case, well, they already have their work there. Let me make it larger here. Hold on, there. And they chose these values at random. They worked the whole thing out. In this case, they got, let's see, oh yes, they substituted into the equation. And let me show you the equation again. It's right there. They substituted those values into the equation. See? And then they perform all the operations, and this is what they got for the y values. Okay, so now we're here at these ordered pairs. These are the solutions of this, with some of the solutions of this equation. Okay, and then they plotted, oops, hold on, and then they plotted these order pairs. Okay, 95, 2, 0, 4, and 5, 6. So they plotted all three there, and we could have done that, I remember, just by using this tiny table. You could have gotten this graph here. Okay, so that's all they did here. And then we need to go back to the question. What is the question? Well, the question is to identify the y-intercepts. The y-intercepts, again, we said that it was when your graph crosses the y-axis. So right there. So what is the y-intercept? The y-intercept is the point 0, 4. Okay. In this case, notice that if any other graph crosses the y-intercept, I mean the y-axis, any other graph really, notice that it's gonna have a value of 0 for x, always. So your x value is always going to be 0 for any graph that crosses the y-axis. Okay. Here, the value of x for this point is still going to be 0. Okay. And that process repeats itself again and again. And that's the same for every graph that crosses the y-axis. Okay. The values for x is always going to be 0, and that's going to be important. You'll see why in a minute. All right, so let's see. Well, let me explain to you why knowing that an ordered pair I mean, the y-intercept is always going to have a value of x equals 0, because if I plug in 0 here for the x, that's going to be 0 times 2 over 5, that's 0. So my answer is y equals 4. So my y variable is going to be 4 if I plug in 0 for x, which is exactly what we did here. So we plugged in 0 for the x into the variable, and we got a y variable of 4, or the order pair 0, 4, and that was our y-intercept. That process repeats itself again and again, because your x variable is always going to be 0 for any graph, well, for any y-intercept. Yeah. All right, let's move on to this example here. Identify the y-intercept. Well, in this case, they're asking us again to identify the y-intercepts. Well, then we just say that we could identify the y-intercept if we substitute 0 for x. Okay, so I don't think we have to work the whole thing out really, as long as we plug in the values, the value of 0 for x. So let me just rewrite everything here. 3y plus 5y equals 0, and then just substitute, I mean x, that's an x, yeah, x, and then just substitute 0 for x, because we're trying to find our y-intercept. Rewrite everything else. 3y plus 5 times 0 equals 0. Okay, so if I multiply 5 times 0, that's 0. Rewrite everything else. Now we have 3y on one side equals 0, and then 3y, we need to solve for y because we want y by itself, because that's going to tell us what y equals to. We use the multiplication principle. Since we are multiplying, we use division. We divide by the number we're trying to move, and we need to do it to both sides to keep it balanced, to keep it mathematically correct. 3 divided by 3 is 1. 1 times y is y, equals 0 divided by 3 is 0. And we have that our y equals 0. Therefore, our order pair is 0 for x, right? And then 0 for y. So that's our order pair, and that's the y-intercept. That's the y-intercept, because remember that all y-intercepts are going to have x values of 0. All y-intercepts are going to have x values of 0. Therefore, you can plug it in. You can plug that value in to the equation and solve for the y variable. All right, so the y-intercept is 0, 0. So we didn't have to notice that we didn't have to do all the work. You know, we didn't have to find points and plot the graph and everything. We went from here to here in one step, and that gave us our y-intercepts. So you don't have to find points like they did here, but if you want to, you can do that. But that's exactly what they're going to teach us, what they're trying to teach us here. Okay, that we can find all the points there, and then wherever your graph crosses the y-axis, that's gonna be your y-intercept. Okay. In this case, we did it in one step just by substituting 0 for the x, since every single time your y-intercept is gonna have an x value of 0. Okay. Solve for the other variable. That's gonna be your y-intercept, your point, the point where you equation, where your graph crosses the y-axis. It's right there. All right. And again, if you wanna do the whole replacing of the x variable and then graph the whole thing, you can do it that way too. It's fine. But just remember that this is a shortcut. This is a shortcut. You can use it. Use it as much as you need, as you can. All right, moving on. I'm just turning the page here. All right. So again, this is one of those problems, and that's a similar problem where we need to identify the y-intercept. Well, in this case, they ask you to graph. If they ask you to graph, then you're gonna have to do it this way, right? The way we've been doing it. So if they ask you to graph, then again, all you have to do is look for x and y. Oops, x and y, and plot, and just choose numbers at random for x. Again, use the smallest ones you can, and in this case I'm going to choose this 3. If that gives me fractions, well, then I can use a different numbers here. Maybe the positive 2 and a negative, a positive and negative 2, yes. Let's see if, hopefully I don't find fractions. Okay, so the equation is 4, and I'm just writing it from up here, 4y plus 3x equals -8. Okay, and then substitute 4y plus 3, oops, x is 1. Okay, substitute that in there, and then solve. That's 4y plus 3 equals -8, and use the addition principle. Since I'm adding here, I need to subtract both sides to keep it balanced. That adds up to 0, so rewrite everything else. Negative and negative, just add them up, keep the sign. That's 11, -11. Here I use the multiplication principle, divide both sides by 4. 4 divided by 4 is 1 times y is y, and that is -11/4. So yeah, it did give me a fraction there, and that's not gonna work. Okay, that gave me a fraction, so I'm gonna need to use a different number for that. Let me go ahead and work out using 0 for x instead. Okay, and this should probably work, since I already know that if I substitute x was 0 for x, that's gonna be my y-intercept, and since they're asking me for my y-intercepts, this should give me an integer instead of a fraction. Okay, that's -8 here, that's 0. So yeah, when I multiply 0 times 3, that's 0. For y, rewrite everything else. Use the multiplication principle. Since I'm multiplying here, I need to divide by 4, the number I'm trying to move. Do it to both sides to keep it balanced. 4 divided by 4 is 1 times y is y. That's equals negative 8 divided by 4 is negative. Since a negative and a positive, I'm dividing a negative and a positive. The answer is going to be negative. 8 divided by 4 is 2. So the answer is y equals negative 2. Negative 2. Alright, so I at least have 1 point. Okay. So let's see if plugging in a negative 1 to the equation is going to give me an integer. Okay, 4y plus 3 times negative 1 equals negative 8. Okay, that's negative 1 times 3 is negative 3. Rewrite everything else. Use the addition principle here. Add 3 to both sides. And that adds up to 0. Rewrite everything else. This is a subtraction. Subtract the smallest one from the largest one. 8 minus 3 is 5. And keep the sign of the largest value. That's 5. That still gave us a fraction. It's gonna give us a fraction, so that's too bad. Use the multiplication principle here. That gave us a fraction. That's too bad. Okay, so if you get a fraction for either your x or y value, go ahead and use a different value here. Okay. So that's not gonna work. That's not gonna work either, because it's difficult to plot fractions. That's why. Okay, so let's go ahead and use 4, like the proof suggests, and negative 4. 4 and negative 4 over here. Okay, so let's do negative 4 first, and I'm going to use a different piece of paper here. And the equation was 4y, oops, yeah, that's it. 4y plus 3 times negative 4 in this case equals negative 8. Negative 4 times 3, that's a positive 3, is negative 12. Rewrite everything else. Use the addition principle to move that 12 over to the other side, and that's gonna add up to 0. Rewrite everything else. This is 12 minus 8. You can think about it as 12 minus 8. The largest for these two values is positive, so the answer is going to be positive. 12 minus 8 is 4, so positive 4. Use the multiplication principle. 4 divided by 4 is 1. 1 times y is y. 4 divided by 4 is 1. So the ordered pair here is 4 and 1. We got a digit there, so that's good. An integer. We got an integer. Now we can plot those. We can plot this ordered pair. What about for when x equals 4? Let me just rewrite the equation here. Oop, that's plus. Well, I messed it up. 4y plus 3 times 4, positive 4 this time. Alright, so let's go ahead and work it out. Rewrite everything. Multiply this. That's 12. Positive and positive. It's going to give you a positive 12. That's negative 8. Use the addition principle. Rewrite everything. These two add up. The answer is going to be negative, so add them up. That's equals 20. use the multiplication principle here. Y equals 20 divided by 4 is 5. Since you have a negative, you're dividing a negative and a positive, the answer is going to be negative. All right. So that's a -5 for this ordered pair. Yeah. And now we have 3 ordered pairs that we can plot. 3 ordered pairs that we can plot. These are the exact same values we have they had in the book. So these are the 3 points when plotted together, okay? And then just use a ruler and draw the graph. All right. We see that our y-intercept is 0, -2, because that's where the graph crosses the y-axis, okay? So that's the y-intercepts. Okay, and we also got that from substituting 0 for x, okay? That gives us y equals -2, because we already knew that any y-intercept has an x value of 0, okay? So those are 2 ways of getting the y-intercepts, by graphing it and by substituting 0 for x into your equation, solving for y. All right, and we're done with that section, okay? And I'm not gonna ask you any word problems for this one, because those have large values, like for decimals, and you're gonna end up just working out like a lot of decimal problems, multiplying and subtracting, dividing, and that's gonna take up a lot of time. But just remember what you have learned from this lesson, which was, let's see, what did we learn? Well, we want to know what happened there. Let me make it brighter here. All right, that's better. All right, so what did we learn? Let's go ahead and recap. Okay, we learned about plotting order pairs or points. Yep. And remember to memorize what the y-axis is, x-axis, the origin. This is what an order pair looks like, or a point. Order pair, memorize that. That's what it looks like, and it has an x and y value. If you're gonna use different variables, just make sure you follow the order in which they come in the alphabet. So for example, P and Q, P will come first, Q will come next after that, okay? And then what else? Oh, quadrants. The first quadrant is this one, second is that one, third one is that one, fourth one is that one. You can think about it as, when using degrees start here to the right and move to the left like that, counterclockwise. That's one way of memorizing that. What else? We found coordinates whenever they gave us the points, okay? Just going backwards, basically. You know that you're gonna have an x and y value. So just go ahead and look at the axis for your x and y values, and that's what's going to tell you what your x and y is. Okay, your x value and your y values are. Okay, and also memorize that the word solution doesn't mean just the answer. No. In mathematics, in algebra, it means either just one value or two values that make the equation true. Okay, that is a solution. If it doesn't make the equation true, if it's false, then this is not a solution. Okay, in this case, this ordered pair is not a solution. 81/6 is not a solution of this equation because it's made the equation false. See? All right. We plotted values by using this kind of table. I made it smaller. Okay. Use that kind of table. Just get random values for x. Get random values for x. Plug them there, and then solve into the equation they give you to solve for y. Okay, that's how you get your ordered pairs whenever you do it by trial and error. Okay, let's see. Okay, let's do graph. To graph an equation. Yeah, to graph an equation means plotting it like this or drawing it like that. That means graphing the equation. Okay. In this case, we're only gonna have linear equations. In other words, graphs that look like lines. Okay. All right. Let's see what else. Exercise. All right. Y-intercepts. We learned about y-intercept. What is a y-intercept? It's just for the line, the point where your graph crosses the y-axis. That's basically what it is. If you can remember that the y-intercept is always going to have an x value of 0. Always. If you can remember that, you can find the y-intercept just by looking at the graph and plugging in the value of 0 for your x. Then just solve for your y, and that's going to be your ordered pair. That is going to be your y-intercept or your points. All right. Let's see what else. Y-intercepts. Yeah, all of this was practicing, and yeah, they're gonna ask you to graph first and then give them the y-intercept. Just go ahead and do that. You know, you already know how to do that by using the table. You know, doing it by trial and error. So graph the equation first, and then find out what your y-intercept is. If you can find out just by graphing the equation, make sure you plug in 0 for x into the equation and solve for y. That's going to be your y-intercepts. And that's it. That's the end of that lesson. Hopefully that helps, and I will see you on the next lesson. Okay.